Before I open the program with GDB, I want to delete these printfs because we already know how printf function works in the low level, and I want my code to be smaller. So I save it, exit, and just compile the program again and execute it. It would execute successfully. Now I say GDB, then the name of the program. So first we create a breakpoint at main and we run, then we change the syntax of the disassembly to Intel, and after that we just say disassemble the main section. Now this is the main section. I'm not going to explain about this instruction one by one and create the stack layout, but I want to give this task to you because we have been doing this a lot of times. You should be completely comfortable with doing something like that. We are going to just go over the codes fast because, as I said, you already know how these things work. I also want to open the strings.c. Now the first instruction says that I want to create an array with these elements, right? So the instruction in here is for the first element. It says move the 0x68 inside the RBP minus 0xa. This RBP minus 0xa would be the address of the first element, or the address that the A in here is pointing to, which is the same thing. What it says is to move 0x68, which 0x68, if you look at the ASCII table, would be equivalent to H, which is this one. After that, it says now that you have moved that, move 1 byte upper because the 0x68, because all the characters are 1 byte, we use 1 byte for it to save it. Then it says 1 byte after that, or higher than that, which is RBP minus 0xt, would be the place that you should move the 0x65. 0x65 in the ASCII table is E. After that, it says the third element would be 0xc, which is should be moved to RBP minus xc, and again 0xc, which should be moved as a byte in the RBP minus p, and at last 0x6f should be moved to RBP minus a. And in this case, after all of these instructions, the array would get created. But after this line, we said that I want to change this element to G, right? So it says the same thing in the assembly. It says, well, it wants the element at A plus 1, right? We said A, the name of the array, is pointing to this one. Therefore, A plus 1 would be RBP minus 0xd, and the content is 0x65. The instruction says that overwrite this 0x65 with 0x67. As you see, we have RBP minus xd, and therefore G would overwrite the E in here, and well, E would be overwritten. That's it. The second instruction has been executed. Now we get to these two instructions, which are for creating a pointer. If you look, it says load the effective address of RIP plus 0x6a inside the RX register. Now what is this address? This address is this one. You see, the GDB has helped us, and it says I calculated the RIP plus 0x8a, and it is equal to this memory address. We want to copy this value, even though none of these instructions has been yet executed. But if I say x and then 1, let's say SG in here to get all the data at this address and hit enter, we already have hello saved in this place. What it means is that hello is not, you see, the reason that we could manipulate the data in the array, the string that we were creating using the array, is that it is on the stack. It is getting created dynamically on the stack, and you could just change it. But about this one is hello is already saved on the data section, which is read only, and we cannot write to that and change that. Now, after the address has been moved and loaded inside the array, so this instruction would load this address inside the RAX register. Then it says now move the same address that you have moved, because we couldn't well move from one place in the memory to another, right? So we first moved it inside the RX register, and then at this place it says now move the address inside the RX register to this location in the stack RBP minus X8. So after this instruction, the address which is pointing to hello in the data section would be moved to RBP minus X8. Now what is this RBP minus X8? It is the address of the pointer. And what is this address? It is the address which is pointing to hello in the data section. So this instruction has been executed. Then we get to b is equal to word. How does it work? Well, it says that word is already put in this location RIP plus 0x85, which is this address. You could make sure of that by copying this value. You see none of this instruction has been executed yet, and we paste it in here, and we have word. Now it says move this address again inside the RX register, then move the same address that is in the RX register to this location. Again, it is RBP minus X8. It is the same thing, but we move different addresses in this location. Now what does this mean? This means that again, let me say in this way, this is the address of the pointer, but these are the address that the pointer is pointing to. First it was pointing to hello, and then we changed it. We said now point to word, but hello and word, they are both written in the and present in the data section. If I want you to completely understand it, I want to use one more printf in here. I say printf, let's say b p, and again p, and again s, and in here I want to say the address of the pointer, the address that the pointer is pointing to, and the string, and I also paste it in here. You see, again, the first one would be the address of the pointer, would be this one, RBP minus X8. The second one would be the address that is inside the pointer, that the pointer is pointing to, and the pointer, at first it is pointing to this one, and then it would point to this one, and at last we have the string. So we expect that the first address is the same, the second would be different. Now let me save it, say gcc strings.c-o strings, and now strings. I forgot to put the \n to go to the next line and make it more readable. GCC, execute it again. You see the address of the pointer is this one. This is the address of the pointer. Then, and it also changes, and it is the this is the first time that the pointer is pointing to hello. Then at the second time this pointer is pointing to word, but the address of the pointer itself does not change. If I execute again, you see these addresses, all of them are changed, but the first address would always remain the same, which is the address at which the pointer resides on. I hope you understand what I said in this lecture. If you don't, please let me know, and I will get back to you in less than 24 hours.